Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Bagusel Saputra and I'm mathematics educational student from 11 Maret University, and today we will talk about derivative. In mathematics, we talk about derivative as a branch of calculus, that is differential calculus. But this time especially we will talk about the application of derivative, that is how to find maximum and minimum value of a function. However, before we learn about how to find a maximum and minimum value of a function, we have to understand some of definition and theorems about derivative as a base. Okay, what will we learn today? On my presentation, the first we will learn about the notation of derivatives. Second, we will learn how to find the derivatives of a function. And the last is how to find maximum and minimum value of a function. Okay, let's start with the first topic. The first topic is about notation of derivative. All operations in mathematics have operators. And to make it easy to write down the operators, we can symbolize operators with a notation. Of course, derivation is also an operation in mathematics, especially operation on a function. So, the derivation has a notation. Let's say we have fx is equal to y. We can denote the derivatives of f by three common notation. First is f prime x, that is the most common notation of derivative. Second is decapitalize x of fx, that is the most common notation of derivative that used in engineering. And then the last notation is Leibniz notation, that denote with dy over dx, but we always say that with dy dx. After we learn about the notation of the derivative of a function, we will move to the next topic, that is talk about how to find the derivative of a function. In this topic, we will talk about the rules for finding derivative. The first rule is called constant function rule. That rule say if fx equal to k, where k is a constant, then for any value of x, f prime x is going to be 0. Then the second rule called identity function rule, that say if fx is equal to x, then f prime of x is going to be 1. Then the next rule called constant multiple rule, that say if k is a constant and g is a differentiable function and f of x is equal to k times g of x, then f prime of x is going to be k times g prime of x. Next is called sum rule. If u and v are differentiable functions and f of x is equal to u of x plus v of x, then f prime of x is going to be u prime of x plus v prime of x. And then the next rule is called difference rule. That is the same with the sum rule, but with different operation. If sum rule with addition, then difference rule with subtraction. Okay. Next is product rule. If u and v are differentiable function and f of x equals u of x times v of x, then f prime of x is going to be u prime of x times v of x plus v prime of x times u of x. And is quotient rule. If u and v are differentiable function and f of x equals u of x over v of x, then f prime of x is going to be v of x times u prime of x minus v prime of x times u of x all over v of x squared. Next is power rule. If f of x equals to x to the power of n, and n is integer or rational number, then f prime of x is equal to n times x to the power of n minus 1. Okay, the last rules is chain rule. Let f of u is equal to y and g of x is u. If g is differentiable at x and f is differentiable at u, then f o g of x is equal to f of g of x, and f o g prime of x is equals to f prime of g of x times g primes of x. To make sure we get the point of the rules for finding derivative, we will try to find the derivative of a function use the rules that we have learned. Okay, let's try with the first function. Okay, the first function is y equals x to the third power minus 2x plus 1, and find the dy dx. Dy dx equals the derivative of x to the third power minus 2x plus 1. That's respect to x, of course. And then we get the dy dx equals the derivative of x cubed minus the derivative of 2x plus the derivative of 1. From the derivative of x cubed, we will get 3 times x to the power of 3 minus 1. And from the derivative of 2x, we will get 2 times the derivative of x. And of course, the derivative of 1 is equals 0. And then we get the dy dx is equal 3 times x squared minus 2 times 1, because the derivative of x is equal to 1. And then the final result, we get the derivative of x cubed minus 2x plus 1 is going to be 3 times x squared minus 2. Okay. Okay, let's move to the next sample. Okay, the second function is similar with the first function, but in this case we raise the function to the power of 20. Yes, that is a big power. And then the dy dx is equal to the derivative of x cubed minus 2x plus 1 all raised to the 20th power. In this case, we will use the chain rule. So we will get the derivative of y is equal to 20 times x cubed minus 2x plus 1, that's all raised to the 19th power, and then times with the derivative of x cubed minus 2x plus 1, that's respect to the value of x. Because the derivative of x cubed minus 2x plus 1 is equal to 3 times x squared plus 2, then we got the result of the derivative of the function is 20 times x cubed minus 2x plus 1 all raised to the power of 19 times 3 times x squared plus 2. Yes. Okay, let's move to the next exercise. In this exercise, we have a function y equals x times x cubed minus 2x plus 1 all raised to the 20th power. So the derivative of that function is equals to x times the derivative of x cubed minus 2x plus 1 all raised to 20 plus x cubed minus 2x plus 1 all raised to the power of 20 times the derivative of x. Because at the last exercise we have the result of derivative of the x cubed minus 2x plus 1 all raised to the 20th power, that's equals to 20 times x cubed minus 2x plus 1 all raised with the 19th power times 3 times x squared plus 2. And then we also know that the derivative of x is equal to 1, so we get the derivative of that function is equal to 20 x times 3 times x squared plus 2 times x cubed minus 2x plus 1 all raised to the 19th power plus x cubed minus 2x plus 1 all raised to the power of 20. After we know how to find the derivative of a function, let's move to the last topic. Yes, the last topic is the main topic that we want to talk today. That is the application of derivative, especially the most common application of derivative, that is how to find the maximum and minimum value of a function. As we know, the definition of a maximum value is the biggest value of quantity, and minimum value is the smallest value of a quantity, of course. But In mathematics, we define this term with a formal definition. That definition say let S domain of F that contain the point C. For the first condition is for any value of x on S, if Fc is greater than or equals to f of x, then Fc is a maximum value of f on S. The second condition is if for any value of x on S, if f of c less than or equals to f of x, then Fc is minimum value of f on S. So if Fc is maxima or maximum value of fx, or Fc is minima or minimum value of fx, then Fc is extreme value of f. Okay, but in here we have a big question, that is where we can find extreme value of a function. But don't worry, in this case we have a useful theorem that's called with critical point theorem. That theorem say let f be defined at I, some interval, yes, and I contains the point C. If Fc is extreme value of f, then C must be a critical point. Or we can say either C is one of an endpoint of I, a stationary point of f, or a singular point of f. A stationary point of f mean the point where f prime of x is equal to 0, and the singular point is the point where f prime of x is undefined. So we can conclude that how to find extreme value of function have two steps. The first step is find the critical points of f on I, and the second step is evaluate all value of f at each of these critical points. If that value of f is the biggest value, so that value is the maximum value of f. But if that value of f is the smallest value, so that value is the minimum value of f. Okay, let's try with a simple problem. That given f of x is equal to x cubed minus 3 times x squared minus 9x plus 14, find the extreme value of f on closed interval from 0 to 4. The first step is find the critical points of f. The first is the endpoints of closed interval from 0 to 4, and we get a 2 point, that is x equal to 0 and x equals to 4. And then the other critical points of f is stationary point and singular point. To find that two kind of points, we must find the derivative of fx or f prime of x with the material of rules for finding derivative that we have learned before, we get the f prime of x is going to be 3 times x squared minus 6x minus 9. Then stationary points of f are points where f prime of x is equals to 0. If f prime of x equals to 0, so 0 equals to 3 times x squared minus 6x minus 9. And then we factorize that equality to find the root of that equality. So we get x equals 3 and x equals to minus 1 as a stationary point of f, but x equals to minus 1 is not eligible because x equals to minus 1 is not inside the interval of 0 to 4. And then singular point of f are points where f prime of x is undefined. F doesn't have singular point because f prime of x is polynomial function and it be defined at every value of x on a real number, especially on the closed interval from 0 to 4. After we get the critical points, the second step is evaluate all value of f at its critical point. Okay, let's see the first critical points. The first critical point is x equals 0. If we substitute the value of x, that's equal to 0. So f of 0 equals 0 to the third power minus 3 times 0 square minus 9 times 0 plus 14. That's of course equals 14. And then the second point is x equals 3. And then we substitute again that value of x to the function. And we get f of 3 is equal to 3 cubed minus 3 times 3 square minus 9 times 3 plus 14. That is going to be minus 13. And then the last point that we have is x equals 4. Then f of 4 is equals 4 cubed minus 3 times 4 square minus 9 times 4 plus 14. That we get minus 18 as a value of f4. If we see that the value of f0, f3 and f4 is equals to negative 18 is the smallest value of f from another critical points. So we can say for f4 is minimum points of f on closed interval 0 to 4. And then f0 is the biggest value of f on another critical points. So f0 is maximum value of f on closed interval from 0 to 4. Okay, that is the first exercise. I hope we got a big picture from my material. Okay, to make sure we get the point from my material, we will try to solve this problem. The problem is find the maximum value of cylinder inside the ball with a radius r. Okay, the first step is find the formula for volume of cylinder. After that, we have to see that formula as a function. Yes, we got the formula of volume of cylinder is P times R squared times H, with R represent radius of cylinder and H is height of cylinder. But in this form, the formula of the volume of cylinder is a function with two independent variables. However, if we want to find the maximum and minimum of a function, we have make sure that the function is depends on one independent variable. But don't worry, let's see the picture. On this picture, if we change the size of H, then the R is also changed, but it doesn't change the size of R. Yes, if change H, R is changed, but R capitalized is not changed. So we can see that R capitalized as a constant. Because of that, we can see the value of R as a function of H. But the problem is we don't know what kind of relation between H and R. Okay, let's see the picture again. We can see 1/2 of H, R and R capitalized form a right triangle, of course, with R as hypotenuse. Because that is a right triangle, so we can apply Pythagoras theorem and get this function of R to the value of H is defined with the square root of R capitalized square minus bracket 1/2 times H close bracket all raised to the second power. And then if we want to see the function of V with one independent variable, we can substitute the function of R to the V function. If we do that, we will get V of H is equals to pi times bracket square root of R capitalized square minus bracket 1/2 times H close bracket square close bracket square times H, and then we'll get V of X equals pi times R squared minus 1/2 H squared times H. And in the final form, we will get V of X is equals to pi times R capitalized square times H minus 1/2 times pi times H cubed, with H on close interval from 0 to R capitalized. Then the second step is find the critical points of V of X. The first kind of critical point is the endpoints of close interval from 0 to 2 times R capitalized, and we get H equals to 0 and H equals 2 times R capitalized as a critical point. And then The next kind of critical points is the stationary points of V and the singular point of V. To find the two kind of points, we must find V prime of H. From the function of V before, we will get the V prime of H is equals to pi times R capital S squared minus 3/4 times pi times H squared. And then the stationary points of V are points where V prime of H equal to 0. If V prime of H equal to 0, so 0 equals to pi times R capital S squared minus 3/4 times pi times H squared. And then we factorize that equation and we get H equals 2/2 times R capitalized times square root of 3 as stationary points of V. And then V doesn't have a singular point because of V prime of X is polynomial of function. The next step is evaluate all value of V at each critical point. Before this, we have three critical points of V, that is H equal to 0, H equal to 2 times R capitalized, and H is equals to 2/3 times R capitalized times square root of 3. Okay, let's see the value of V at each critical point. When H is equals to 0, V of 0 is equal to P times R capital squared times 0 minus 1/4 times P times 0's cube. That's of course equals 0. When H equals twice of R capitalized, we get the value of V of twice of R capitalized is equals 0. And then if H is equal to 2/3 times R capitalized times 3 square root of 3, we get the value of V is equal to 4/9 times square root of 3 times pi times R cube. From that value, we know that 4/9 times square root of 3 times pi times R capitalized cube is more than 0. So that is the value, the maximum value of V. That we know V is the formula of for the volume of cylinder inside the ball. From that, we can conclude that the maximum volume of cylinder that inside the ball is 4/9 times square root of 3 times pi times R capitalized cube. Or we can say because 4/3 times P times R capitalized cube is the volume of ball, we can say the maximum volume of cylinder that inside the ball is 1/3 times volume of ball times square root of 3.
Okay, let's visualize the V function that we got via Geogebra to see where the maximum point is. First, create a slider r because we have r as a constant that we can replace by any real number in open interval from 0 to infinity. Then write down the function that we get, that is y equal to pi times r square times x minus 1/4 times p, times p times x to the third power. And then don't forget to write down the definition interval, that is close interval from 0 to r capitalized. Finally, we can pay attention with the graphic of our function. Wait a minute. Then we can see the maximum point of our function. We can look the graphic. Then we can also change the value of r to see the change of the maximum point that we got. Okay, I think that is my visualization of our function with Geogebra.
Okay, I think that's all for my material today. I hope all of you can understand and get the point from my material. Thanks for your attention. See you and wassalamualaikum warahmatullahi wabarakatuh.